This lesson is going to cover our learning target 4 of the quadratic unit, writing quadratic functions. Our EQ is how do you write a quadratic function when given information or a table. I need you to remember that a y-intercept occurs when an x is equal to 0. So when input, remember a y-intercept occurs when x equals 0. So when the input is 0, the number you get for your y, for your output, that's your y-intercept. It's important knowing this going forward because we're going to need to use that especially when we look at tables. So for example, what is the y-intercept for the equation y equals 2x squared minus 3x plus 6? To do this, we need to input 0 and see what the output is, the y. So I'm going to replace all the x's with our 0. So 2 times 0 squared minus 3 times 0 plus 6. 2 times 0 squared is 0, 3 times 0 is 0, and 0 minus 0 plus 6 will equal 6. So my y-intercept for this equation is actually the 6 that we had in the original equation. So going forward, it's important to know that once you have identified the y-intercept, you have identified the c that you're going to plug into standard form so we can actually write down our equations. Let's try an example where we need to write a quadratic function using some given information. The information that's given to us is the vertex of the parabola at 3, -4, and a point that is actually sitting on the parabola that's not necessarily special, but it is one of the points you would find actually if you're graphing the parabola, and that's at 2, -3. Since you're given a vertex, then I think the better path to creating a function, to creating an equation, is to use vertex form. So that's kind of like a nice key word to look for, is if you see vertex, you should be using vertex form. Remember, vertex form is y equals a times x minus h squared plus k. So in our given information, we're given our h and our k. So I'm going to go ahead and plug these into the h and the k. So our x is -3 squared minus 4. Now I'm almost done in creating my equation. The only thing that's missing is what number is the a. To do this, we need to create an equation that would only have the a in it. We have an x and a y. Well, lucky for us, the 2 is an x and the -3 is a y. So I need to substitute those into the x and the y, and then I can solve for my a. So now my work would say -3 equals a times 2 minus 3 squared minus 4. Now I have a problem that only has the a in it, and I can simplify and solve for a to figure out what should be plugged into this spot in my answer. So doing that, so simplifying this gives me -3 equals a times 1 squared minus 4. -3 equals 1 times a is a minus 4. Add 4 to both sides, and I get a of 1. Now that I have an a equal to 1 and an h of 3 and a k of 4, I can now write my final answer. My final answer is y is equal to 1 times x minus 3 squared minus 4. So now I have created my equation in vertex form using the given information. Since it's a 1 in front of the x minus h parentheses, it is optional whether you want to write it or not. It's completely up to you. The second way that we need to know how to create an equation from is from a table. That's part of our EQ. So if we're given a table that looks like this, there's a few more steps we have to do in order to get to our final answer, which is the function, which is the equation. When we were trying to create equations that were linear, back in Unit 1, we created what was a difference table. So what I want to do is start to create a difference table using the numbers I see here. Remember, we gray out this part right here, and we start to work ourselves backwards. Negative 105 minus 72 is negative 33. Negative 72 minus negative 45 is negative 27. And negative 45 minus 24, negative 21. Negative 24 minus negative 9 will give me negative 15. Typically, what we'd want is a constant difference to figure out our slope. But since we're working with parabolas and quadratics, they're curves, so they don't actually have a slope. So doing this isn't enough. We need to figure out what is constant about these differences. We call this the second difference. Again, we're not going to have anything in this cell and not going to have anything in this cell. Starting with negative 33 minus 27 gives me negative 6. Negative 27 minus 21 is also negative 6. And negative 21 minus negative 15 is negative 6. So the constant is actually in our second difference. When creating a quadratic equation, we refer to this as the 2a column. And since it's the 2a column, we can actually set a small little equation. 2a is equal to negative 6. So what is a? A is equal to negative 3. I now have an a to plug into my equation. Now up here, there's no information about our vertex. So using vertex form is not helpful when creating a quadratic function from a table. Instead, what we want to do is use standard form. Standard form is y equals ax squared plus bx plus c. We're given an a, so that's awesome. We can definitely plug in our negative 3 into this a spot, and that's one step closer. The other thing we need to notice is in the table, we have actually a y-intercept. Y-intercepts happen when you plug a 0 in for x. So when I plug a 0 in for x, I get negative 9. So negative 9 is my y-intercept. And as we found in the very first example of this lesson, the y-intercept is actually the c. So now I have both an a and a c to plug into our standard form. So let's start by plugging in what we know. Y equals negative 3x squared plus bx minus 9. I don't know the b yet, but I could know the b if I were to plug in something for the x's and also for the y. Now to do that, we just need to pick any other point on our table, and then we'll be able to solve for the b. I see that I have another point at 1 and negative 24, so I'm going to plug those in. I get negative 24 equals negative 3 times 1 squared plus b is that x in there is now a 1 and then minus 9. So once I start to simplify this, I end up with negative 24 equals 1 squared is 1 times negative 3 is negative 3 plus 1 times b is b minus 9. The nice thing about picking a point that uses 1 for x is you end up with just a b and you don't have to worry about numbers in front. Let's add 9 to both sides and add 3 to both sides, and that gives us an answer of negative 12. So now I have a b, and I have an a, and I have a c, and now we can put all those into standard form and write our final answer. So the final answer is y equals negative 3 squared minus 12x minus 9. Remember that all this starts from creating not just a difference column, but a second difference column. The second difference column is actually 2a, so remember to divide it by 2 to get the true a that we use to actually write down the equation for the table. Go back and rewatch any portions that you think you need a little bit of help on. Don't forget to answer the questions and hit the submit button after you're done with this. And if there's any remaining questions you think you have about the video and the notes, please write them down in your left column and bring them in the class.